This is our charging and discharging circuit. So to start off with setting up the circuit, we used our function generator over here on the right. We set it to 600 hertz and square waves, and we use that to power our circuit. Once over into our circuit, we added the power through our resistor. Then that went through the capacitor and went back out. And then these cables connected to the capacitor were then connected to the oscilloscope, taken through the capacitor to put the output onto the oscilloscope. That image is shown here. Once connected to the oscilloscope from our circuit, this is the output onto the screen. The channel 2 blue line being our circuit output along here. The bolded line right there that just popped up is the charging stage of the capacitor. And then this is a representation of the discharging stage of the capacitor. This equation was then used, our charging and discharging equation, V out equals VI times E to the negative T over tau. This would be our equation for charging and discharging. And we are able to use this equation to turn into a half-time equation by simply just solving for T. VI being 5 volts and V out being 2.5 volts. So taking that to the other side to 1/2 equals E to the negative T over tau. Changing that to ln 1/2 equals to negative T over tau. And finally solving for T equal to negative tau ln of 1/2. This equation can then be compared to our calculated value. So we added in RC for tau and found that T is equal to 70. And this can be found on our oscilloscope by adding in our first cursor at 5 volts and our second cursor at 2.5 volts. And this showed an output of 80. So that was very close to our calculated value of 70, plus or minus some errors using the oscilloscope.